What was the first use of aerodynamics in bridges? Have you ever wondered how bridges withstand the forces of nature, especially wind? The story of aerodynamics in bridge design is fascinating and begins with a significant event. The first major use of aerodynamics in bridge design came after the collapse of the Tacoma Narrows Bridge in 1940. This incident revealed how wind forces could impact long-span suspension bridges dramatically. Before this, engineers focused mainly on static strength and deflection, often ignoring how wind could affect their structures. The Tacoma Narrows Bridge was completed in 1940 and was designed to be lighter and narrower. However, this design did not account for aerodynamic stability. As a result, the bridge twisted and oscillated violently in the wind until it ultimately collapsed. This disaster was a wake-up call for engineers, prompting them to investigate how aerodynamic forces could affect bridge performance. After the collapse, engineers began conducting pioneering studies on aerodynamics. They performed dynamic model tests to simulate how bridges would react to wind forces. These tests uncovered unexpected modes of motion, such as torsional twisting, which were essential for understanding how bridges behave under aerodynamic loads. The first intentional aerodynamic design innovation appeared in the 1960s with the construction of the Severn Bridge in the United Kingdom. Engineers designed the bridge deck with an aerofoil-shaped box girder. This design was inspired by aerodynamic principles and aimed to reduce wind resistance while improving stability. This approach was revolutionary because it focused on eliminating aerodynamic disturbances rather than just resisting them. As a result, bridges could be built lighter and more efficiently. The integration of aerodynamic testing and design principles became standard practice in bridge engineering by the mid-20th century. The Severn Bridge stands as a landmark example of this innovation, marking the beginning of modern aerodynamic bridge design. This shift allowed engineers to balance structural efficiency with wind stability, ensuring that bridges could withstand the forces of nature while serving urban and infrastructure development needs. In summary, the first practical use of aerodynamics in bridge building was a direct result of the Tacoma Narrows Bridge failure. This led to a new era in bridge design, where understanding wind forces became essential for creating safe and effective structures.